Hey everybody, this is Brad Dyke saying hi. Um, there is a point of what I call mass, critical mass, might be the better word to use. And that relates to the fact that when you deal with hundreds of disks in your test lab, as I do, eventually the little suckers replicate, right? Like rabbits. So you have to kind of stop, take a breather for a second or two, and then at that point in stage, realize what you're dealing with. Excuse me. The reality is that you have a lot of these hard drives, right? And you're going to have to take a little bit of time and manage them. Now, I don't mean manage them as in they're in your disk arrays. I mean manage them so that they're stored correctly when not in use. The problem that ends up happening with hard drives, you see, especially with this industry days, is that we tend to discard them kind of on the go, right? So the problem with that kind of approach is you start mixing the disks, you start mixing the performances and so on and so on, and then you have to go through a test model of some type to test the drives, make sure that they're still good, make sure they're, the proper speeds and so on. And it gets pretty tedious when you have a laptop sitting aside here on the sidelines doing what you need to do, and you find out at the end of the day, as you've done it, that you've mixed bad drives with good drives, because let's face it, most of us don't throw away hard drives when they go bad. We kind of keep them around because sometimes we want the neodymium magnets to, have fun with our kids or something like that. When we work with disks, as you can see here, and we have them as they might be, in this case, SSD, right? There's 24 of them right here. And then down here, we have 10,000 RPM drives, which are really good for their day. And then also down, and maybe the farther section, we'll have 10,000 RPM in a different channel set, which is for slightly slower performance. And of course, you have the worst, which is way down here, and that is SATA. And this is encompassing. I mean, up here you've got an EMC disk array. Down here you've got a NetApp array. Way over here, and if you can look over here, is a 3-par. And you've got a Dell array, and you've got HP Classics up here. And the end result is, when you're trying to get all this done, and you're cycling out disks in that process, the end result turns out to be basically, in a nutshell, total confusion. So what do you do to do this? Well, the very first thing I would suggest you to do is you do teardowns via by modules. In other words, don't tear down a NetApp and an EMC array at the same time, because what ends up happening is you have an entourage of different caddies and fillers and so on that end up just creating a bunch of mess. Be pragmatic about the approach of hard drive management. Pull the drives out in sequence or in out of sequence if you're going to do a complete rebuild, as you see here with SSD drives, right? And I put those down here, and you pull them all out and you get them staged first in groups. Now, the good news is, because you stage these in groups, it allows you to keep the things kind of structured and organized, right? And that's a good thing. Now, you also will have blank trays. I'll show you a value about these trays later, just as an example that's really cool and that is feasible to do, but not today. And so on and so on. Now, as I pull more of these out, now I'm getting into the low tier SSD 7200 RPMs. And this is why I tell you, make sure that when you do this, that you're classifying these drives correctly while you've got them out, right? So in just one storage array, I have done quite a bit actually, right? So these are all spinning disks right here on the outer channel. And I have a set of Teams SSDs, and then I have the Team Group SSDs. Let me show you what that looks like. Okay, as you can see here, we have a large number of these 1 terabyte SSD drives, which are the later generation. I'm sorry, the newer generation. Here we have our Team Series SPs, which are decent and they're functional, but these particular guys are set up in such a way so that they can provide some staging disk capacity. And there's a small number of them right here, but they're different. So here I have my 1 terabyte drives here. I have my SSD drive standard here. I have my 7200 RPM SATA disks right here. And they're all on, if you look up here, they're all coming out of this 3-channel bay. 1 channel, 2 channel, 3 channel. Now, this is already starting to become confusing because out of just a single disk array, as you can see here, I have got some convolution, right? Imagine what would happen if I started pulling out these guys on top and trying to keep them classified as well correctly, and only to find that I'm in my situation is it gotten worse. So I have to go through next couple of weeks here pretty much inventorying all of my disks out there. And so right here is a good example of Dells that I have sitting right here. And this is a quad server, and this guy alone can handle 12 hard drives all by itself. And I'm going to restage some disks to bring these in, but before I can do that, I need to inventory everything. Then I got to test everything that I want to use, and I'm going to use an array, one of these arrays, to do that testing in bulk. And I've had a lot of people requesting, asking me, hey, how do you do this? I mean, how is this accomplished? How do you manage all this? And you know what? It's managed by the way we try to get this in a manageable format, but also be flexible. As you can see here, I'm in the process of putting these back in sequences so that I know exactly which ones I've got, which ones I don't have, and I will be able to say, at least for these, by even just putting them in, notice how I'm closing the locks on them, telling me that everything that's got a lock on it but won't go into the bay. See how they still float? Right there, let me adjust this for you. See how they just float in there? And this guy can be a divider because he has no value right now. And I'm putting all of these 1 terabyte drives in because this is my quote-unquote bastration array. I have broken it so I can do SSD and gotten it to communicate the way I want it to do. That's do it right. And I get that going. You never know what happens, right? So here I've got all of 1 class hard drive here. And then I will put my divider in. This is my divider, and I'll put him in like so. And I'm going to put him all the way in. Now he's locked in. He's the only one in that setup that is locked in. Next, I'm going to take the next classification I've got here, because this is writing on 1 bay, and this is in this, 1 channel, which ends right here. You pull that little tab out if you want to. I can do that. Let me do that. Why not? Because I really want you guys to remember that when you're managing your disks, especially in storage-wise, you know what you're doing in regards to keeping things the right way. So here I've got these 3 separate drives, and they're to be treated as standalone drives. I'll put that in. But I'm going to leave the handles up. See what I'm doing? And then at that point in stage, I still have one 2 terabyte hard drive, which I haven't decided what I'm going to do with that yet. I'm thinking of just leaving it out. But now what I'm going to do is I'm going to put the SSD drives in. I'm sorry, I'm not going to do that. I'm going to put the SATA standardized 7200 RPM drives in. But it's going to start right here on the third bus. Okay? And they're all locked down, which basically means in a nutshell, they're not going to be able to sleeve into their slots. Now this is a hot swappable bay, so I can do this. And I'm using my disk array panel here as my organizer. Instead of trying to put these in boxes or plastic bags or whatever you do, don't make the mistake of putting in a, I guess you'd call it a hard drive caddy hat housing thingamajiggy that can sleeve and pocket hard drives, kind of like how this is doing it here. I find that just kind of weird because working people don't have those problems, right? They are, they're just trying to get to where they want to be. And I've seen guys who have walls and walls and walls of hard drive caddy housings, and those disks just sit there forever and they just don't do anything. Just reuse your disk arrays as part of your managing tool. Like for right here, I've got 600 gig drives right here. These are really nice disks. They do a great job. I've used them for a couple of years as my primary disk repository, but it's time to break this array. It's time to make it do stuff it's never done before. And what I mean by that, I'll give you an example. First, let me check here. Yeah. So what I mean by is that I want to basically break these. And what I mean, I'll show you here in just a second. Okay, so I've showed you guys basically my strategy of just using disk arrays to manage my disks, because I can test the arrays, I can test the drives, I can reorganize, I can recycle drives, and so on, as well as manage them. But here's the thing I was telling you about. This little guy right here. Now, the difference between him and the difference between him is that little bridge card you see right there. You see that? Now, this guy doesn't do so well when it doesn't have a caddy inside it. But this guy does. Now, that's important. If you really want to think outside the box, keep that in the back of your mind. Now, I'm using this to manage, I'm using this disk array to manage the disks, but can I also use the same strategy to break an array? Now, breaking an array doesn't mean I'm going to take a hammer to it. What I'm basically saying is I'm going to take this as the standard, and I'm going to redefine that standard. Now, what do I mean? Well, let me give you an example. I'm not doing anything really special here, to be honest with you. I'm not. I'm just looking at something, and I think, hey, I could do it differently. That's all. And that's exactly what I'm doing here. In my day job as a director of operations and DevOps, I do a lot of things that go by the standard practice. But I also know the protocol environments, and I also know the hardware environments as well. So when you come across an SSD drive like this, which is basically your typical SSD low-cost drive, I'm going to break it, open it up, right? And I'm going to have in my possession the SSD drive. Here it is. Not this. This. I can also put additional heat sinks on this, which sometimes I do, sometimes I don't. There's an aluminum spread that's very nice and thin. You can put it on the chips, and it comes out about that far from the chips. And it's just a heat dissipator, and it will just guarantee the full life of the integrated circuits themselves. because they do kind of get a little warm. Not really bad, but they do get warm. So, how does this deal with this? Good question. Now, since the weight of this little daughter card is absolutely extremely light, I could technically break some rules with that. I remove the 2.5-inch hard disk, in this case at 15,000 RPM rock and roll drive, right? I remove it for it giving me this. You know what? I could do something with this. So what I can do is I can actually do that. Look at that. Look at all the air that's in here. Remember what I told you about that small little heatsink combo? No interference whatsoever. Look at the clearance on that. 10 millimeters, maybe 9 millimeters. Free drift. And wow, it fits. So with that being said, I could put 1 terabyte redacted format interfaces, remove all the security functionalities out of it, hence the word redact, pardon the phrase. Just get all that component out of the equation. Just put the standardized SSD SATA interface on board, because this does SAS or SATA. Can't beat that either, right? This is a DS2246 array, NetApp-wise. It's a native device interface. It can run like crazy, and it's highly redundant. And with that, since it has an open back-end protocol, that means Smart 2, when it comes out, will run just fine. All you need is a controller card that can run Smart 2, and that means you can finally use some APM, that's Advanced Power Management, on these hard drives. And look at this. No issue. It just goes right in. Isn't that slick? Now, with that being said, I can make sure I find my drive here. Yeah, here it is. That guy is pretty awesome. But what else can I do with this? You know what? I put a chassis drive, a caddy drive in here that has nothing on it. Couldn't I do the same thing with this as I could do with this? Let's find out. Yes, I can. Check that out. Again, about 9 millimeter of clearance there. And on this end, I've got, that looks pretty good to me. I'd say about 2.5 millimeter. Let's see if it will take. Look at that. Took without a problem. Of course, I'll have to run the test on that to see how feasible it would work. But as you can see, we just broke the bank. We could absolutely reinvent these arrays to do a lot more, because I have just ordered NVMe and M.2 daughter bridge cards that are just a little longer than these, and they'll take the M.2 slot, and it has a basic interface on it. Now I got to be honest with you, this guy's a little rocky, it's kind of flimsy, so it does and it is built more for putting a hard drive within the housing of this caddy, but it still goes in just fine. It's just not as sturdy as I'd like to call it, because even in general it's kind of not very strong. You gotta be careful with these, though the size and the functionality of this array does beat the 2246, so I'll work with this for now and I'll experiment more with these. But I will be honest with you, these are sturdy, these are nice and strong. And not only these, but if I reach way over here and I pull out one of these, I could possibly, with a caddy, as you can see here, put an SSD drive in this as well. Now, the bad thing about 3PARs is they're kind of temperamental. You have to be patient with them. They just, they're just grumpy, in my opinion. They still work. It's just you gotta break the pathways and so on. But all of this capacity you see over here and all this capacity you see here, you can use this to manage and organize and retest and just do everything you want to do instead of trying to build a diagnostic station or something like that. If you've got a spare disk array, why not? I mean, that just makes perfect sense. The other key thing that's important here to realize that by recycling these older HP style hard drives that you've got in these traditional style G7s, G8s, and over here you've got some G6s and so on, yeah, you can reuse them, and you should. They're great for building up large disk capacity functions, like here I've got with the Dell array here. This is a Linux box, and so on and so on. So organize your disks. Use your disk arrays in different ways so that you'll have functionality, right? Why not? You know, if you're not sure if a disk is not good, go ahead and mount it up in a caddy. It's safer that way, right? And all you have to do is just simply, at minimum, put 2 screws in. Preferably put 4 screws in, because that adds strength to the caddy, right? And by getting the caddy to work correctly and be strong enough to do what needs to be done, the drive will snugly fit perfectly every time. Sometimes when you do crisscross screws, like one here and then one over here, you'll get a bit of a torque on the drive. The other reason why you should do 4 screws is because if a drive can actually float, even partially float, it can have some issues. If you know this, you also know that hard drives are sensitive to noise. And you can actually scream at your hard drives while you watch your disk performance report analyzer, right? And the hard drives will actually reflect or respond to the sound waves that are hitting the disk arrays. That's why we don't have a lot of noise these days in data centers. They're fairly quiet. Way back in the day, we used to have Liebert arrays that would be sent out, and they would blow hard air and so on. But as they blow the hard air aimed at the arrays, no one thought that the ambient noise inside the facility was actually having somewhat of a performance impact. So we began to displace the heating solutions into the ceilings and into the floors and away, so the air handler noise could be somewhat controlled better and keep that performance level at as highest level as possible. Now, one last thing you'll also want to do when you start managing your disks is you're going to find out that just disks that just are slow, specifically SATA 7200 RPM drives. They might be big. They might be 6 terabytes or 8 terabytes or 12 terabytes, but they are spinning disks, so their level of IOPS is lower than that of SSD drives, right? So, with that being said, keep your expectations in check and classify your disks in such a way so that you've got all of that slow stuff way over there for the NAS side of your discussions, and you've got all your performance stuff over here for your application side, and your SSDs are for your high end or your absolute point end IOPS requirements, such as a quad array or something like that. Yes, if you have a quad array, a quad array is 4 CPUs. Those are your heaviest hitting and biggest monsters most of us will get our hands on. There are more out there than that, but they're much rarer these days to find because there just isn't a demand to them like there used to be. A lot of times you'll find cores that will have 4 core processors and 8 GPUs that they can handle, and then that becomes a compute cycle both for inbound and outbound. Remember, GPUs process differently and are more like as I say, a surgical process opposed to the more common process of a CPU. That's why they can't be put in the same classification. You have to kind of segment them apart from each other. But with that being said, use your disk arrays smart. When you're not powering them up, use them to manage your disks, track your disks. When you have to test your disks, use the same thing that was storing your disk for temporary storage as your test array. Refer to the videos which I provided in my past few years about formatting disks. You can just do a standard format. Formatting, it takes time, but it's an excellent diagnostic tool for a healthy disk. If you go out and you buy 520 formatted disks, then use my videos to get them to the standard 512 format, and use the multi-version formatting tool video that I have to help you do many disks at once. I've done 24 disks in one round, or you can just do one. But managing your disks with your disk arrays really does cut down on all the unnecessary boxes and plastic containers and this and that and so on. It never fails though. They reproduce like bunnies, and next thing you know, you got more hard drives and you know what to do with. What do? Sell them. 15 bucks, 10 bucks a piece. Even if they're fairly big, just sell them, take them to a convention or somewhere and see if anybody wants to buy any hard drives. Rock and roll, sell them as is. They work. Maybe one day they won't. But you've had your fun with them and you've moved on to bigger and better capacities. And that's what really basically matters here. So, with that being said, I thought, I'd take a little bit of time here to talk about management. I'm going to have to I really tore up my lab to rebuild my lab. To rebuild the racks and to rebuild the infrastructure and get 10 gigabit bandwidth architectures fully deployed, and so on and so on and so on. My lab and my infrastructure have taken a little bit of a beating. So as I start getting into this, I'm managing, and I thought, well, this is the same kind of stuff I did in data centers way back when, and I could relay this kind of management to you if you would like, if not, just end the video and move on to the next video, right? But this is Brad Dyke, just giving you a little bit of advice on how to start managing things in your lab. If you have an interest in me in more stuff in regards to managing and how to organize the non-technical stuff, everything from documentation to just getting your gear stowed away correctly so you know where it is when you need it, and so on and so on, let me know. I'll make some more videos, because that's exactly what I'm going to have to do here in the next, I'd say 3 or 4 weeks. Sit on the floor like I'm doing right now, get my trusty screwdrivers, move all the disks that I'm not using out to places where I can store them safely, and prepare to put other things away, network cables, LAN cables, all that wonderful fun stuff, and get them set aside in such a way. Other things such as metalworks, that would be your plates, your 1U plates, 2Us, 4Us, 16Us, 8Us, your shelving or rack components for shelving your servers, or other metals that just kind of lay around that you wish you had had a place to store them. Take a little time and just get yourself organized. I think you'll find yourself in a much better place when you know where everything is placed. Also, a great suggestion for that, even with hard drives, but be careful. Plastic boxes, specifically storage plastic boxes, are notorious for generating static electricity. If the right material, i.e. wool or cotton or things like that, brush up against that plastic, you can generate a static field that can possibly damage anything you have in them. So if you're going to store delicate items, right, in such storage bins like you can get at Menards or Lowe's or something like that, and it's big, it's got a big plastic lid on the top and all that, make sure that you use your static bags to put your gear into that before you put them in there, and close them taped tight shut. That will keep the static discharges from ever finding a home and wiping out your electronics. even though electronics are fairly competent and capable, they are still sensitive to the stronger levels of static discharge. So it's always important to make sure you address static discharge when you're dealing with equipment, moving a lot of equipment around, and so on, that has sensitive electronics like hard drives and so on in them. Outside of that, cardboard boxes are better, but they tend to get wet and soppy, so it's still not a bad idea to put them in, some IO bags or some static discharge bags. If you've got them laying around from all those times you bought stuff, why not? Just go ahead and do it. Outside of that, that's pretty much it. The last thing I'll say about managing hard disks is don't be afraid to retire disks. Even if you put them in a dead box, right? Move the box out of your lab. Put it down in the basement. Put it somewhere else. A pet project for you to take the hard drives apart and get the neodyme magnets or whatever out of them, the disks or whatever floats your boat. The point is, clear your lab so you have space. I guarantee you, if you clean up your lab, I'll get all your hard drives and all of that organized, and you have clean surfaces on your lab, all of a sudden you're going to want to do new projects. So, anyways, all right, it's past 30 minutes now in this discussion, and this is just I doubt if I'll have 20 people who hit this video, because most of you are interested in doing technology, not managing your gear. So, with that being said, this is Brad Dyke signing off. You guys have a great time. Take care. Bye-bye.